Hello and welcome to yet another episode of our sequences and series where we shall be focusing more on the quadratic pattern. Okay, so starting with the definition, we know that quadratic pattern is basically a sequence of numbers in which the second difference is a constant. So the keywords here will be the second difference being a constant that will create a quadratic pattern. Okay, so let's have a look at this example. So if we have our numbers 1, 2, 4, 7, 11, and so on, okay, this is our pattern. So we can say that there is the first difference between the numbers. Let's see. So if we get our T2 minus T1, that's 2 minus 1 is a 1, 4 minus 2 is a 2, 7 minus 4 is a 3, 11 minus 7 is a 4. So these will represent what we call the first differences, okay? But we can see that these first differences are not the same. They are different, okay? Which means we can go on and look for the second differences, okay? Which must be the same. So between 2 and 1, it's a 1. Between 2 and 3 is a 1. Between 3 and 4 is a 1, okay? That's 2 minus 1 is a 1. 3 minus 2 is a 1, and so on and so forth. So now this becomes our second difference. And for as long as that second difference is made up of a constant number or variable, then we can go on and conclude that the pattern or the sequence is quadratic. Okay, so they're telling us that we noticed that the second differences are all equal to 1, and any sequence that has a common difference, a common second difference, will be known as a quadratic sequence. It's also important to note that the first difference of the quadratic must form an arithmetic or a linear pattern, okay? So that the second one just becomes the constant. Okay, so we know that the general term of a quadratic is given as n squared plus bn plus c, where a, b, and c, these are integers. They can be positive or negative numbers, okay? So we're trying to see how do we obtain the general term of a quadratic sequence. So we're saying that if we had to look for the first term, replace n with 1. Okay, that will represent the T1 in this case. That will give us a plus b plus c, where n is a 1. So 1 squared is a 1, and then 1 times b is a b, and so on and so forth. Then if n is a 2 for the second term, that's going to be 2 squared, which is a 4. That's 4a, and then 2 times b is a 2b plus a c. So this is our T2. Okay, T1, T2. Same thing with T3, same thing with T4. Then let's try to extract what we called the first differences. So with the first difference, what we know that 4a minus a is going to give us 3a, and then 2b minus a b is going to give us just a b. The c's will cancel out. Between T2 and T3, 9a minus 4a, that's going to be a 5a, then 3b minus 2b, that's going to be a b, and then the c's also do the cancelling out. Then T4 and T3, the difference between that is 16a minus a 9a, that's a 7a. Then a 4b minus a 3b, that's a b, the c's will cancel out. So this represents what we call the first differences. Okay, then we go on and get the second difference, which must be a constant. Okay, so that's going to be 5a minus 3a, which is a 2a, and then 7a minus 5a, which is a 2a. The b's will go out. So this represents what we call the second differences. All right, so we can see that the second differences are constant. They are uniform and unique. Okay, so when we are determining the general term, our point of interest will be this 2a. Okay, in other words, we must find the second difference. Like in this case, this one will be equated to the 2a, and then we look for the value of a. Then the 3a plus b. Okay, remember this is the first difference, number 1 of the first differences. So we shall equate it to this number 1 here. Okay, so it's the same number as this one. And then lastly, I have my a plus b plus c. A plus b plus c, I will equate it to the first term. Yes, so we're having a lot of ones here. Okay, so that is that. So a plus b plus c, this is the first term of the quadratic. okay, number one of the quadratic. 3a plus b, this is the first term of the first differences, and then 2a will be the first term of the second difference, so any other number of the second difference. All right, so in each case, they're telling us common difference is a 2a. Perfect. Let's look at this example. So we're just going to look at random variables, a, g, f, and I, no problem. So they're asking us to determine the second difference between the terms of the following sequences. So the point of interest is basically the second difference. All right, let's see. So we know that T2 minus T1, that's 20 minus 5, that's going to be a 15. And then 45 minus 20 is that, help me guys, 45 minus 20. I don't know. Someone saying 25. Okay, thank you. And then 80 minus 45. 80 minus 45, which gives us 35. So this is just the first differences. And then when we look at the second difference, 25 minus 15, that's a 10. Same story, 35 minus 25, which is also a 10. So which means our second difference is just a 10. All right, let's look at G. Then we go to F, no problem. We have 2 minus 1, that's going to be a 3. And then 9 minus 2, that's going to be a 7. And then 20 minus 9, that's going to be 11. And then we also find that 7 minus 3 is a 4. 11 minus 7, which is a 4. So which means our second difference here is a 4. In this case, it was a 10. All right, then let's look at F. So with F, we have 0, negative 6, negative 16, and so on. Okay, so the story continues, T2 minus T1, which is going to give us a negative 6. And then negative 16 minus 6, that's going to give me a negative 10. And then negative 30 minus 16, which is a negative 14. Okay, so let's get our second differences. So that's going to be a minus 4, then a minus 4. So our second difference here is negative 4. All right, then I look at I, we have 3a plus 1. So I'll take this as one term. Then this also as another term. That's also another term. And then the story continues. So the difference there, and then the difference there. So 12a minus 3a. Remember, this is algebra, so it has to be the common terms together. So 12 minus 3, that's going to be 9a. The ones will cancel. Then 27 minus 12, that's going to be 15a. And then 48 minus 27, that's going to give me a 21a. Okay, then our second differences is going to be just 6a. 6a, because 15 minus 9, that gives us the 6. All right, so that represents our second difference, and that will be just the first example of how we determine the second differences in each case. Please, when you're getting the differences, it has to be the consecutive terms, okay? The higher value term minus the other, so it's like a T2 minus T1, T3 minus T2, and so on and so forth. All right, so we go on to the worked examples, just a few of them, and then, yeah. Okay, question 1, consider the following number pattern. We have 21, 20, 29, 48, 77. They want us to get the general term. Now, remember I said this general term is the same as the nth term, or the rule, and so on and so forth. So if we have 21, we have 20, we have 29, we have 48, we have 77. In most cases, they give something like this. It could be a quadratic if I look at just the marker location, but let me not be 2 for 1. So let's get the difference there. So 21 and 20. So in other words, 20 minus 21, which gives us a negative 1. And then 29 minus 20, that's going to be 9. And then 48 minus 29. That gives me a 19. And then 7 minus 48. That gives me a 29. Okay, so we're seeing the numbers are different. Let's see if there's something unique between the two. So 9 minus minus 1, which gives me a 10. 19 minus that, it's a 10. 29 minus that, which is a 10. So this is a quadratic pattern. All right, so we said this 10 is going to be equated to the 2a. So say my 2a is equal to 10. For me to get the value of a, I'll divide both sides by 2. And then my a is going to be a 5. Then this negative 3 must be equated to the 3a plus b. So I'll say 3a plus b should be equated to negative 1. But since our a is a 5, just substitute. So 3 times 5 plus a b must give us negative 1. Then 3 by 5 is 15. Let's move it that side, which is going to be negative 1 minus 15, which becomes negative 16. And then lastly, we said this 21, the first term, should be equated to the a plus b plus c. So a plus b plus c must give us a 21. But now, since our a is a 5, our b is a negative 16, and then our c that we don't know. Do your magic, and let's get the answer. So that's 21. I'll say plus 16 minus 5, which gives me a 32. Okay, so C is a 32. Then if I have my A, B, and C, then I can go on and write out the general term. So that's going to be 5n squared minus 16n, and then plus a 32. So sometimes this is the n is just in terms of n. Okay, it could be possible that they ask you for the TP, which means your variable must be P. Okay. All right, so that is how I would have approached that question for the 4 marks. Then let's look at part B. They're telling us that we have 2x, y, 26 is a quadratic. Okay, here they are being specific. They're telling us. The second difference is 3. All right, determine the values of x and y. Determine the values of x and y. Okay, let me just jot it this side. 2x, y, 26. So we have a 2, we have x, we have y, and then we have 26. Okay, but what they told us is that the second difference is a 3. So what I'm going to do is second difference is equal to 3. Okay, let me get the first differences. So we know that t2 minus t1, that's going to be x minus 2. And then this is going to be y minus x. This must be 26 minus y. Let me get my second differences. So I have this minus that. So let me just put it in brackets, say y minus x minus the whole of x minus 2. And then this side, we're going to have 26 minus y minus the whole of this, which is y minus x. But one thing we know is that, okay, before we know anything, let me just simplify this further. So opening this up, I'll have y minus 2x. That and that is going to be a plus 2. Okay. Then in this case, I'm going to have something like a 26 minus 2y, and then this is plus x. All right. So now, one thing we know is that the second difference is a 3. In other words, the whole of this is equal to 3. The whole of this is equal to 3. So what I'll do, how many marks is this thing? It's 6 marks, no? Yeah, I think it's worthwhile. So what I'll do, I'll just equate each of them to 3 and then solve the 2 equations simultaneously, since we know that even these 2 must be equivalent to each other. All right, so what we're gonna do, we're gonna say y minus 2x plus 2 is equal to 3. That's my equation 1. And then the 26 minus 2y plus x must also be equivalent to 3. That's our equation 2. Let's just leave the variables on one side, okay? All right, so I'm gonna move the 2 that side, then move the x that side, so I make y the subject. So y is gonna be 3 minus 2, which is a 1, plus 2x. That's my equation star. Then I'm gonna get this, replace it where I see y, so I get the value of x. So substitute star into equation number 2. So that's gonna be a 26 minus 2 into 1 plus 2x. Okay, plus x should give us a 3. Then that's gonna be 26 minus a 2 minus 4x plus x should give us a 3. So 26 minus 2, that's a 24. Then if we move that 24, that side gonna be negative 24. So 3 minus 24, which is negative 21, okay? So negative 21, this side we're gonna have a negative 3x. Divide both sides by negative 3, which means x is 7. Then substitute this into equation star, which means our y is gonna be 1 plus 2 times 7, which means the y is 15. All right, so that is how we would have approached that question. Yes, it's hectic now, but it's possible for a question like that to be asked. All right, question 2. Question 2, at a fruit market, boxes of apples were arranged according to the following pattern. So pattern number 1 is having 3 boxes. Pattern number 2 is gonna be 2, 4, 6. That's gonna be 8. And in this case, we have 1, 2, 3, 4, 5, and then 3, which is 15. All right, so what we see is that we have a pattern of 3, pattern of 8, and then 15. Then how many apples are there in the next pattern? Okay, let's see. How many apples are there in the next pattern? So let's see how the pattern is growing. So from here, we're seeing a plus 5 now. And then there, we're seeing a plus 7. And then what? Next one must be a plus 9. So what is 15 plus 9? We must have 24 boxes. 24 boxes of apples in the next one. All right. So the answer for 2.1 is just going to be a 24. And then can we show that the number of boxes in the nth pattern are given by this? So they want us to find the Tn. So remember what we said? We need to find the second difference, which is going to be a 2. Which is going to be a 2. So this equated to 2a. This equated to 3a plus b. And then the first term should be equated to the a plus b plus c. So they just want us to prove that it's that. So what we can do is 2a is 2, divide both sides by 2, which means a is 1. Then we move on to find the b. So 3a plus b is equivalent to, we said it's a 5, no? Good. Then 3 times 1 is a 3, so it's going to be 3 plus b is a 5. Move the 3 that side, which means b is a 2. Then lastly, we have a plus b plus c should be equated to 3. Okay, a plus b plus c is equated to 3. Our a is a 1, our b is a 2, so a 1 plus 2 is a 3. We subtract, which means c is going to be a 0. So therefore, Tn is going to be n squared, 1n squared, which is n squared, plus 2n. All right. Then 2.3, which term of the pattern has 960 boxes? So in other words, they are asking for the position. Okay, if this one continues, we're going to have 960 boxes somewhere there. So we want us to get the n. So just get the Tn, and where there is Tn, we're going to represent the 960. We're looking for the n. So we shall have n squared plus 2n should be equivalent to 960. And then let's solve the quadratic. Okay, so move the 960 aside. So n squared plus 2n minus 960 should be equivalent to 0. Okay. So if that is true, what we need to do is you can use your quadratic formula, or you can use the factors. It is up to you. What we need is basically the answer. So if I'm to use my factors, I know that it can be n and n. 960, 960, 960. It's gonna make sense. If I use 32 and 30, because I see that's the closest that's gonna give me a positive 2. So it's positives, negative. Let's see. Plus 32 minus 30. Okay, you can use the quadratic formula. There's no problem. Okay, because that's n squared. That's going to be negative 30 plus da 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 da. Okay, and then when I multiply 32 by 30, I get the 960. Okay, which is perfect. It's a perfect combination. So solving this, n is going to be a negative 32, or n is going to be a 30. But now, since we're talking about positions, we cannot have a negative position, okay? So we're gonna get rid of that, and then we focus on position number 30. All right, we move on. Probably the last question, telling us that the first 4 terms of a quadratic pattern are negative 1, 2, 9, and 20. Determine the general term. Okay, so I think I can jot it here. So we have negative 1, we have a 2, we have 9, we have 20. So step number 1 is for us to get the first differences and the second differences. So 2 minus minus 1, that's a 3. And then 9 minus that is a 7. And then that is going to be 11. And then that's a 2, never. So we have 7 minus 3 is a 4. 11 minus 7 is a 4. Okay, so our second difference is a 4. So we say this equated to 2a. This must be equated to the 3a plus b. This must be equated to the a plus b plus c. So we shall have 2a is equal to 4, divide both sides by 2, which means our a is a 2. Then 3a plus b is equal to 3. But our a is a 2, so that's 3 times 2, which is a 6. So 6 plus a b is equal to 3. You translate that to that side. That's going to be 3 minus 6, which is a negative 3. Ne? All right. Then lastly, we have the a plus b plus c is equal to a negative 1. Good. Then let's substitute. So if our a is a 2, our b is a negative 3, then we're looking for c. So we know that 2 and that is negative 1, which means the c is going to be a 0. Okay. So the Tn is going to be 2n squared minus 3n. All right. So that is the first part, 3.1. Then 3.2, calculate the 48th term of the quadratic. So 48th. So which means they're looking for t 48. So where there is n, put a 48 or substitute a 48. So 2 by 48 squared minus 3 by 48. Just use your calculator and get your answer. Okay. So 2 by 48 squared, all right, minus 3 by 48. So what I'm getting is 4464. So 4464. So that represents the final answer. And I'll stop there for now, okay? But there are more questions that we shall look at in our extended revision, whereby we shall be looking at all the different types of sequencer series, the geometric, the quadratic, as well as the arithmetic combined. Okay, for now, I'll sign out till we meet again. Bye-bye.